Alright, hi everybody. Happy Friday. Again, we're doing video notes again today. My host of people hope competition's going well. For the rest of you guys in class, hang in there, just a half day today. Okay. So we're talking about section 9.1 today. So we're doing intro to sequences and series. So this is something I'm pretty sure you're familiar with from Algebra 2, possibly Algebra 1 as well. Okay, so we're just going to kind of go through our big vocab here in the first video. Second video, we'll do some examples. I'm just going to follow along with the worksheet that you have in front of you. Okay, so we'll kind of talk through some of this stuff. Okay, learning targets are at the top, so feel free to go ahead and copy those. Okay, so obviously the first topic is a sequence. So sequence is just a list of numbers with a given order. Right? So we're going to start at 1 and count upwards. So for instance, I might say that the first number in my list is 5. Okay, now we're going to use this notation with the lowercase a most of the time, and then what number it is in our list. Okay, and then maybe the second number in my list is a 7. Third number in my list is 15, maybe. Okay, so on and so forth. Most of the time, the sequences that we're going to be interested in, there's going to be some rule for how we get from one term in the sequence to the next. Okay, so as you hear, I add 2 to get from the first to the second term, but then I add by 8 to get to the third term. Maybe there's a rule there, maybe there's not. Okay, so a sequence doesn't necessarily have to have a rule. Most of the ones that we're going to work with, they will. Okay, so again, each of those numbers in my list are going to be called a term. Okay. Now I may just have maybe 10 numbers in my list. Okay, for example, that would be called a finite sequence, right? I have a beginning and an end to my list. It could also be an infinite sequence. So like the one I wrote at the top here, with these dots kind of going to the right, that means my sequence is going to go on forever and ever. It's never going to stop. Okay, so that means we have an infinite sequence. Now the other big topic in this section, what we call a series. So instead of just having a list of numbers, okay, in a series, we're going to take that list and we're going to add all of our terms together. Okay. Now, typically when we see these, we're going to use this thing called summation notation. Okay. So the summation notation is this guy over here. Okay. This large Greek letter sigma. Okay. That's what the kind of E-looking shape is. Okay. What this means, and I have some of the vocab underneath here. So this letter I, highlight that. So this I here, okay, that's our index of summation right there. Okay. So that's just the letter we're going to use to represent what number in the list we're working with. And then we're going to go from starting at, in this case, the first term in the list, and then going up to the nth term in the list. So that's the upper limit of our summation. So maybe I want to add up everything from the first to the 12th term in my list. Okay, well, if I want to do that, I'd go from my indexes. Oh, come back. All right. So in that case, I would want to go from I equals 1. It's my first number. If I'm counting up to my 12th, okay, then we're going to go up to 12, and then whatever my rule is here. Okay. So again, that would be adding everything from the first number in my list to the 12th number in my list. Okay, and we're just going to add them all together. Okay. So again, in the bottom we have our lower limit of summation. At the top we have our upper limit. And that's going to be the big idea with our series. Typically with our series, you're going to see the summation notation and then have to calculate the sum from there. Okay. Typically in this class, we're just going to be calculating finite sums. In some really special situations, we might get a chance to calculate some infinite series, but that's a really big topic in Calc 2. And hopefully I can give you guys a preview of that next week. Kind of some really interesting things happen with infinite series. But I won't spoil the fun yet. Last big vocab word I want to go over is this word factorial. Again, one that I believe you're familiar with. Okay, Again, that just means we're going to multiply all the numbers up to whatever number we choose. Okay, so if I want to do 7 factorial, okay, by factorial, we're going to use this exclamation point. That doesn't mean I'm very excited about the number 7. Okay, that's a specific function here. Okay, and that means I'm taking the number 7 times 6 times 4, 5 times 4 times 3 times 2 times 1. Okay, obviously, because of the way we're setting this up, factorials grow very, very fast. Okay, so already this would be a pretty huge number. Okay, we're only at 7. One weird thing you should be aware of, just by convention, and for a couple of reasons, we're going to define 0 factorial equal to 1. Okay, so know that if you ever encounter 0 factorial, that's not equal to 0, that is in fact equal to 1. Okay, so let's go ahead, let's play around with some examples, and see kind of what sort of problems you're going to see, kind of things you're going to be asked. Okay. So one common problem, okay, might look like, I give you the rule, and I want you to tell me some of the terms in this sequence. So I've got this first example here where it says a sub n is equal to 2 to the power n over the quantity 3n plus 1. Okay. Well, again, I'm going to start at 1 and just start figuring out what these terms are. So I would say that a sub 1, well, that's 2 to the first power over 3 times 1 plus 1. Right, everywhere I see an n in this formula, I'm going to plug in my first number 1 here. Okay, well, that's just 2 over 4 equals a half. Okay, well, now let's look at our second term. So the second number in my list, well, now that's going to be 2 squared over 3 times 2 plus 1. So that's 4 over 7. Okay. A sub 3. Well, now we've got 2 cubed over 3 times 3 plus 1. So that's 8 over 10. Okay. Which is, right, let's simplify that. That's 4/5. Okay. So I've got the first 3 terms in my list. I've got 1/2, 4/7, 4/5, okay, in that order. So I'll leave it to you. You go ahead and find terms number 4 and 5. Okay, just to go ahead and do the same thing. If we jump down to number 2 here, okay, this is something that's you should really become familiar with. You're going to see these powers of -1 appear a lot. And what that's going to do is that's going to make the terms in our sequence change signs. So we're going to go from positive to negative to positive, right? Because as we increase values of n by 1 each time, it's going to go from odd to even to odd to even, and that's going to cause this to go from negative, positive, or the other direction. Okay. So again, let's see what a couple terms here look like. So we've got, again, a sub 1. Well, let's plug in 1 everywhere for n. So we've got -1 to the n times 5 minus, oh, sorry, that should be n. Start over here. Okay, so this is -1 to the first times 5 minus 2 times 1. Okay, well, -1 to the first is -1. So I've got negative 5 minus 2. Well, that's 3. So my first term would be -3. Okay. Try to save space here. Do one more. Second term in my sequence would be -1 squared. And again, that's going to be 1. So that's going to cancel out here. And that's 5 minus 2 times 2. Well, 2 times 2 is 4. So a sub 2 is going to be 5 minus 4 is 1. So same thing. Hopefully you didn't take up as much space as me. Go ahead and find a couple more terms in the sequence. And what you should notice is that it's going to go from negative to positive, negative, positive. and so on and so forth. Now, on to number 3 here. So now we're going to go in the other direction. So instead of giving you the rule and asking you to come up with some of the terms, okay, now I'm going to go ahead and give you some of the terms in this list, and I want you to come up with the expression or the rule that's generating this list. Okay. So this is where there's no necessarily trick to this or one set strategy that's going to work every time. I just need you to use your brains a little bit here. Okay, notice some of the patterns and fight with it a little bit. These could be hard potentially. Just go ahead and do your best. So what do we notice about this sequence? Okay, well, from 3 to 7, okay, well, I added 4 there. Then 7 to 11, add 4 plus 4. Okay. So that's a pretty easy pattern to recognize, right? Each number in my list, I go up by 4 each time. Okay. But I know that I want a sub 1 to be 3. I want a sub 2 to be 7. Okay. So in my rule, I need to be able to plug in 1 and get 3. Okay. Since I'm going up by 4 each time I increase my n by 1, I know I should have a 4n in my formula here. Okay, because again, each time I increase n by 1, I go one more term in my list, my value goes up by 4. Okay. Well, but again, if I know if I plug in 1, I should get 3. So, okay. Well, when I plug in 1 here, well, that would be 4 equals 3, which doesn't work. So I need kind of like a -1 here. So the way I would write out this rule, and again, this might be obvious, and maybe I'm dragging this out a little bit, okay, but just starting to recognize some of the strategies we can use to take this pattern that we notice to construct our rule. Okay? So here I would say that our nth term, okay, looks like it's 4n minus 1. And again, we can go back and check. If I plug in 1, so now my first term should be 4 minus 1 is 3. Good. My second term should be 4 times 2 is 8, minus 1 is 7. And you can keep checking, and it looks like that works. Okay. So let's try the second one. So it's a little hard to tell from the first 2 terms, but what seems to be going on with our later terms, so starting kind of in this category. Okay, well, it looks like my terms, okay, it looks like 2 to a power. Well, since this, for instance, this here, this is n equals 3, it's being raised to the power 2. This is n equals 5, it's being raised to the power 4. Okay. So the power is 1 less than whatever number in my list. Okay, so I'm going to say we're taking 2 to the power n minus 1. Okay, but what's going on in the bottom here? Okay, maybe this part's a little trickier. Again, let's start to notice what's happening with each of these. So I'm going to go ahead and do a little erasing real quick. So from 2 to 6, eraser stone. From 2 to 6, right, I multiplied by 3, then I multiplied by 4, then I multiplied by 5, right, so I'm multiplying by 1 more each time. Okay. Well, again, that looks a lot like our factorial formula we looked at earlier. Okay, so what we actually end up with here, okay, is 2 to the n minus 1 over n factorial. Okay, about to run out of time on this video. Go ahead and check for yourself that this one works. Okay, and we'll jump into the last video to finish up the examples.